and has mass is called
Matter.
Okay. So anything? That by space matter. Okay. So if I'm having this, first of all, matter, you know very well, you are very much familiar that matters is made up of atoms and molecules. You have studied. Okay. So first of all, if I'm saying that, if I just say that anything on the earth, matter has been divided into two parts. One is living matter, living things, living things. Another one is the non-living things. Hmm? Now this non-living things, on the basis of the physical properties of how the particles of or the atoms and molecules are combined in this one, we have divided this into three main categories. Okay, solid, liquid, and gases. Okay,
Okay.
so we have divided the matter into three things: solid, liquid, and gas. So that is solid, liquid, and
Yes.
gas. Yes, there are the other states also, that is plasma and both acid and condensate, but we don't study them in the next study. Okay.
Okay.
So what happens in solid, actually, you know very well that solids are the matter in which atoms are tightly packed together. In which atoms are very tightly packed together. The other one is the liquids that are going, in which the atoms are not tightly packed and there is an intermolecular space is present. Intermolecular space is also present in the solids, that you see that here, like this one. Here is intermolecular space. Here is intermolecular space. Okay, but as comparison to that of liquids, the intermolecular space in solid is very, very less. Okay. The third state is gas. This is solid. This is liquid. The next one is gas. That is one particle here, another particle here. Okay, that is gas. Particles are very, very far away from each other. Okay. So solid, liquid, and gas are the three main forms of matter, of non-living matter. Okay. And we have divided it on the basis is that the atoms, how the atoms are connected, or the how the atoms are packed. Okay. If they are closely packed, then they are solid. If they are having space, they are movable. They can move from one position to another position. Okay, they have some kinetic energy. They are moving. Okay, they have molecular space, so that we can simply say that they are considered to be as liquid. And if there is a large space and they are easily compressible, and they are going to have very high kinetic energy, then they are considered to be as gas. So if I told you that what is solid, liquid, and gas, so let's write the characteristics of solid. First of all, in solids, particles are loosely or tightly packed. Particles means atoms. Okay, particles are
Tightly
packed. Okay, they have fixed position. They don't leave their position. And and vibrate about their position, mean position. Vibrate about their mean position means they just vibrate like this one, just at their mean position. Okay, so they vibrate about their mean position means they are not moving here and there, they are just vibrating about their mean position. Okay, they can't flow, or we can say that they have fixed position. It means we can say that they can't flow. They can't flow. Okay, so i.e. we can say in the bracket that they can't flow. They have very less intermolecular molecular space. Intermolecular or interatomic space. Intermolecular space. Very less intermolecular space. They have very little. They are incompressible. They are incompressible. They are incompressible. Generally, we can't compress this one. Okay, got it. You understood?
Yes, sir.
And the next one is they have high densities. They have high densities. They have generally high densities. Density. Now you understood what is density? What is density? Density is if I'm saying that if you are having a glass of water, okay.
Okay.
And similar, if I'm saying that you are having a glass of honey, which will be much heavier, glass of water or glass of honey?
Glass of honey.
Honey. So this means that in the same amount of glass, more weight of honey can come. So, just imagine
Yeah.
that instead of this honey, if we have some solid substance like we have some metals, okay, and this glass is filled with some metals, so it will be much heavier than the honey also. Okay. So if I'm saying, so they have generally high densities. Generally, why? Because there are some metals that are going to have low densities. There are some substances in solids also. Okay, like a sponge, if I'm having, so if sponge is having very low density. Okay, so generally have high densities. So that's why a word is written here, that is generally. Okay, got it? They are
Yeah.
incompressible. They have very less intermolecular space. They have fixed positions. Okay, and they have fixed volume. They have fixed fixed volume, or we can say definite volume. They have
Defined volume.
definite volume and shape. There is some shape. If you are having a mobile phone, so it will not shape like a remote next morning if you wake up. So it will not behave like a remote or a cup of tea. Okay, a cup of tea will remain as a cup of tea. It will not become a jar. Okay, so that are going to have the fixed shape because the particles stick together at a particular position. They are not continuously moving. Okay, so if
Okay.
the particles are responsible for changing the shape, now if you pour a glass of water into some other vessels, that is going to have some different shape. So that water is going to take the shape of that vessel. So why? Because the particles can arrange themselves accordingly. But in solid, can you do this one? No.
So,
Okay. So they have definite shape. So note it down.
so I can't say the first one.
Okay.
First, yeah.
Okay.
Finished, sir.
Done?
Yeah.
Okay, not this one.
Yes, sir.
If I ask you a simple question that I'm saying that they are incompressible, then why the sponge is compressible? You have taken the sponge. Have you seen sponge
Yeah.
that you usually use in the bed? The bed mattresses are made up of sponges. Okay, so you see that they are made up of these things or substance that are made up of sponge. They are just compressible. Sponge is generally compressible. Okay,
Yeah.
so why the sponge is compressible?
I don't know.
You don't know. Okay, let me explain you. Actually, if I zoom it out, okay. For example, if I'm having this sponge, okay,
Okay.
let this is a portion of a sponge. Okay, this I'm having making here. Okay, this is a sponge. And I have just taken this part only. And I'm just zooming this one here. Okay. So if I zoom it out, you will see that there are the air space present here in this sponge.
Yeah.
So when we press the sponge, the air comes out. Actually,
Yeah.
sponge is designed in such a way that it is going to have air holes. Okay. That is not
Okay.
going to have the sponge there. That the solid substance are not present there. Okay. So
Yeah.
when we press it, the place where the air is present or the holes where the air is present, the air comes out from that one and then it get compressed. Okay. So that's why sponge is. But when you compress, you can compress the sponge for to a particular limit. To a particular limit, up to where? If the whole the air has come out, you cannot further press it. Okay. You can press it till an amount, till a limit. You cannot press it as a whole. Okay. Because when they come together, when the air comes out from these holes, what is going to happen? The solid will come together and you cannot press it further. Okay. So this are simple questions that we say that we say that solids are compressibles. Solids are compressible. Then then why sponge get compressed?
If the air removed,
Hmm. So I'm going to write the answer for the sponge contain air holes. Air holes. Bracket, in bracket we can write no solid matter is present in the holes.
uh,
The holes. Okay, bracket close means where the hole is there, where the air is present, there is no solid matter is present. Okay,
yes.
when we press it, the air from holes rushes out, rushes out, and solid matter come together. This can't be pressed further. Okay. This, okay. The sponge contains air hose. No solid matter is present in the hose. When we press it, the air from the hose rushes out and the solid matter come together. This can't be pressed further if air is, okay, means the sponge can't be pressed further. Okay, you understood, Rima?
Yeah. Yes, sir.
Okay, note it down.
Okay. Then, sir.
Okay, let's move further. Now, talking to the states of liquids. Liquids, you know that liquids are gas. The liquids are the, we can simply say that they in this the particles are continuously moving. Okay, and this is the next form of solids. Means when we melt solid, it becomes liquid. So you know that the liquids particles are going to have some intermolecular space. Okay,
Yeah.
and their particles are continuously moving. They have some kinetic energy. Understood? So if I'm
Yes, sir.
saying that in liquids, in liquids, particles are loosely packed as comparison to solids. As comparison to solids, they have some kinetic energy. They have kinetic energy. Kinetic energy. Liquids don't have fixed shape as as the particles. Particles are continuously moving, but they have they have fixed volume because because particles of liquids have enough force of attraction, enough force of attraction between them. And last, liquids can't fill the container completely.
So, what do you write the last one? Last point.
Liquids can't fill the container completely.
Okay. Done, sir.
Done.
Yeah.
Okay, let me explain you that liquids, why if I'm saying that liquid is going to have fixed volume but don't have the fixed shape. Okay, why? Because the particles of liquids are continuously moving.
Yeah.
Okay, they are continuously moving in any random direction. Okay, but what happens that why the liquids have fixed volume? For example, if you are having a 2 liter of water, you can't fill when you pour it into the bottle of 5 liter. Will it completely fill that one? No.
No.
Will it fill? If you are having a two
No.
liter water only and you pour that water into a 5 liter bottle, it will not fill. Why? Because the
Yeah.
particles of liquids attract each other. They are going to have the top surface particles are being attracted with the particles that are present lower than, okay, and the side. So they don't escape there. They don't have such much kinetic energy that they can leave their surfaces. Okay, so that's why they can't fill. But in case of gases, this kinetic energy is so high that they can easily escape from the surface. Okay, and then resulting in the means they can fill the container. Okay, so if I'm saying that why the liquids cannot fill the container completely, and if I'm just saying that why liquid have fixed volume, this is just because in liquids the particles are attracted with each other. They have a force of attraction between them, and it this result that the particles cannot easily leave. Okay, got my
Okay.
point? Now
Yes.
the next point that we have discussed, liquids, in liquids, the particles are loosely packed. Okay. And the second one is
Yeah.
they have kinetic energy. They don't have fixed shape. You know very well they don't have fixed shapes. The particles means if we pour the liquid in a particular content that is going to have a particular shape, then it will take the shape of that container. As a result, if I'm saying this, moreover, they have fixed volume. Okay, and they are also incompressible. Okay, some liquids we use in the brake oil is used in the brake in the cars. Okay, or in the motorbikes. So why we are using the brake oil? Because this is a property of liquid that it can take the shape of the pipe from which it is going, if we cannot have some solid like this. And moreover, when we press the brake, the clutch or the brake, then it apply the force on the pedal. Okay, so because it is not compressible, that why almost non-compressible. So we can say that we can write a point here that liquids liquids are almost incompressible. Okay, now moving to the next point is about the gases. So the particles are, you can simply say that this the particles of gases are They neither have fixed shape nor fixed volume. Okay. So if I'm saying that the particle of gases are very much separated apart, so it means that they are going to have very large, very high intermolecular space. They are very much separated. They can fill the container completely. Why they can fill the container completely? Because they have very high kinetic energy and they have very low force of attraction. So particles can move in any direction. Okay, they are
Yeah.
not tightly bonded. They have neither fixed shape nor fixed volume. So means if I am having a half liter of gas, then it can fill the container of 5 liter. Okay. Have you seen these cylinders in India that generally they are, if the gases is very low in very low amount, is still the nozzle is at the top. Okay. But in case if the liquid, if there is a liquid filled in the cylinder, then how will it goes upside? No. We generally put the tap on the lower bottom of the container that is filled with the liquid in order to get like in water cooler. Okay. So we don't have the tap at the top because they don't fill that, because when the water level becomes low, then you cannot have the water from the top. Okay. So but in case of gases, we have this the output of gas in the cylinder at the top, because gases can fill the container completely. You understood? They don't have much effect of gravity. Okay. So they have neither fixed shape nor fixed volume. Means they can have, means I'm saying that they can fill the container completely, because if you are having a half liter of volume of gas, then it can fill the 5 liter of container. Okay. Okay.
Yeah.
Like similarly, the spray also, we continuously use the spray, the deodorants, but when it becomes very low in amount, then still the spray is coming out from that one. Okay. So, and moreover, they have fixed shape. They neither have fixed shape. Why? Because they can be poured into any container. Moreover, if I'm saying that, wait, and if I'm saying that both gases and liquids are called fluids. Both gases and liquids are fluid. Are fluid. Okay? Both liquid and gases are fluid. Means they can flow. Okay. Both liquid and gases, i.e., they can flow.
Mm.
They can flow. Okay. Flow does not mean that only the liquid can flow. Okay.
Okay.
Okay. So, and they are highly compressible. Gases are highly
Complete.
compressible. Okay, so note it down. Done. And remove.
Yes, I do. Yes, sir. Yeah.
Okay. So let's move further. Let's move further. So if I'm saying, let's move the properties of the characteristics of particles of matters. Okay.
Okay.
Characteristics of particles of matter. So characteristics, what does the word characteristics means? The features. For example, if you are having a phone, then what are the characteristics of a phone? Phone have a display. Okay. It has a battery. Okay. And we can communicate with this one. Okay. So these are the characteristics of a phone. Okay. Similarly, a schools, the characteristics of a school, that there must be teachers, there must be benches, there must be boards. Okay. So these are the characteristics. So similarly, if I'm saying that what are the characteristics of particle of matter, that so if I'm saying that particles of matters, particle of matter are very, very small. Second one, particles of matter have a space between them. Space between them. Third, particle of matters are continuously moving. Fourth, the particle of matters, particles of matters. Understood? Rima, where have you gone?
Can you hear
Yeah,
me?
yeah, I can hear you, but you are not visible. Yes. The particles of matters are very, very small. The particles of matters have a space between them. The particles of matters are continuously moving. And okay, these are the important properties we're going to discuss first. Then we're going to discuss the part and the other one also. Okay. Particles of matter attract each other. Attract
Each other.
each other. Okay, so let's do the first property. The particles of matters are very, very small. Okay. So how can you prove this activity by showing activity that particles are very, very small? So let's you have an example. Suppose if you have 100 ml of potassium permanganate solution. This is a potassium permanganate solution. Okay, that is pink in color. How it is? It is pink in color. Okay, so this is dark pink in color. This is like this. This is dark pink in color. Okay.
Okay.
So if you have this is 100 ml. Let's see this 100 ml. In the another container, you are having a pure water.
Yeah.
Pure water that is not added with something. Okay. And this is 90 ml. This is 90 ml pure water. And you add 10 ml 10 ml of this solution to this one. Okay. You are just pouring it. Okay. Let me have the color again. Okay. So you are pouring this one. Okay. This one. You know that this color will become a little bit lighter. Okay. Now this color will become a little bit lighter. Okay. The solution will become lighter. Now this further, if you repeat this one, we are having another 90 ml fresh water. 90 ml fresh water. And similarly you take the sample of this one from this sample. Okay, and you are just pouring this one here.
There will be little bit color.
It will form some color to it. It will give some color to it. Okay. And then this will become more lighter in color. Okay. Got it, Rima? This will become more lighter color. Similarly, when you go through this one for 2 or 3 times, you will feel that every time the color will become lighter and lighter in weight, lighter and lighter. Okay, but it will going to have some color. Okay, so if the particle of the size is very, very small, sorry, if the part let's assume the particle size is is not very, very small. So let's suppose if you take some water from it, if you take some, let's suppose these are the size of the particles. This is water, this is the particle size. Okay, so when you take some particle from this one, then you pour it to this one, then this particle will go into this solution. Okay, these three particles will go into this solution, and then you take another one, then it might be possible that you pour it to, then it will become more. And the next one, it might be possible that you must not have taken this particle remain here, you pour it to this one. Okay, so this will not change the color. So if the particle size is bigger, then it will not continuously keep on changing the color. It will become lighter in weight, but it will not continuously keep on changing the color. Okay, if you repeat this at least 10 times to 15 times, then it still the color will be appearing. Okay, understood? Still the color will be appearing. So this shows that the particles of metals are very small. Okay, so first draw this one, then I'm going to explain you. Draw one more time.
Yes, I'm done.
Done. Okay, so note it down that the particles of metals are very small. Particle of matter are very, very, very. Show this the activity. Take 100 ml of potassium permanganate. Potassium permanganate solution and 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 taking now this this sample added to 90 ml pure water. Again, take this, take the again, take the 10 ml solution from beaker to and pour it to third beaker containing 90 ml fresh water. Repeat. Then 5 to 6 beaker. Observation. We will observe that that the color of solution become lighter as we from beaker 2 to 6. second to sixth. Put it down till yet. Till here.
Yes, sir.
And
Yeah.
now the next results. What is the result of the activity? Particle of matter is very small in size as it is continuously giving color color fresh water. Okay, got it? Got it, Rima?
Yes, sir.
Got it down.
I'm done.
Next, the particles of matter. The next characteristics is the
So
particle
one
of,
second, I didn't write the last one.
put
A
it down.
second, yeah. Yeah, done.
Next,
Yeah.
the particle of matter is continuously moving. Give an idea. Give me some idea that you can say the particles of matter are continuously moving. Hmm? Do you have some examples? How can you say the particles of matter are continuously moving?
Because of the air.
Because of the air.
Yeah.
Air is also matter. Tell me.
Um,
Give some example that will prove you that particles of matter is continuously moving.
mm, mm, mm.
Don't have any idea. Let's
Wait.
suppose if I'm this is a stove. Okay, I'm just going to make it very hard. And the food is cooking over it. Okay, you feel that a smell from the stoves reaches to different part of the home. Why it reaches to the different part of your home? How it reaches to a different part of your home? Hmm? Smell of the cooking food, like if you are having a instant stick agarbatti. You know what is agarbatti? Hmm?
So,
This is a instance. When you light it up, then the smell of this one reaches to the different part of this. And why it reaches? Because the particles of matters are continuously moving. Okay. So simply this can be explained by the example that the smell of the food, the smell of cooking food reaches reaches from home, from kitchen to bedroom. Because a particle of matter are continuously got it.
Yeah. Wait, sir.
Put it down.
Done, sir.
If I ask you a simple question, that
Yeah.
why, if I ask you a simple question, Hashit, your class will be after, means it will start after 7 minutes. Okay, are you getting me, Hashit? Are you there? Okay. So if I'm saying simply that the smell of the cooking food, if I ask you that the smell of the cooking food reaches much faster than
Yeah.
the uh, you are very much familiar that if you open the refrigerator, okay, the food is present in that one. The smell of that food does not reaches to instantly to different part. But when the food is being cooked from the kitchen, then the smell of the cooking food reaches to the bedroom. Why? If you open the refrigerator, the smell that is the food that is kept in the refrigerator, the smell of that food is not reaching as faster as the smell of the cooking food reaches. Why? You have any idea? Hmm?
We are cooking food and it's being hot.
Hmm. So,
Um, So the smell will come to every rooms and everywhere.
because it is hot. So if something is hot, then what does it have in the form of energy? Does it have more energy or less energy?
More energy.
Yes. And which energy? Kinetic or potential? Which energy it is going to have? Kinetic or potential?
Kinetic energy.
Kinetic energy it is going to have. Nah?
Yeah.
Okay. So if I'm saying that if the cooking food is hot, so it is going to have more kinetic energy, and more kinetic energy means more faster rate the particle can travel. Got it? At more faster rate the particle can travel. And if it can travel at faster rate, then what is going to happen? The particles of food is going to travel to at faster rate. Okay. But if you kept that food in the refrigerator, then the things that are very cold or that are cooler that don't have the much energy. Okay, much kinetic energy. So their particles cannot move at very fast rate. Okay. So when you open the refrigerator, the food kept in the refrigerator, the particles from that one are not moving at faster rate. But when you cook the food, the particles can move faster because the food is hot and is going to have more kinetic energy. Okay, you understood, Rima?
Yes.
So note it down. Why the cooking food question? Why the smell? Why the smell of cooking food reaches to at faster rate smell of food kept in
1 second, let me write, sir.
refrigerator. Okay,
Yeah.
so let's write the answer. The cooking food. The cooking food particles have more kinetic energy than the particle of food kept in refrigerator. So they travel at faster rate. You understood?
Yeah, I understand.
So, so cooking food particles travel at faster. So cooking food particles travel at faster rate. Please note it down.
Answer.
So Rima, that's all for today. We'll meet you in the next class. Okay.
Okay, thank you, sir.
We'll discuss. Okay.
Bye.